Okay, problem 15 from 2025 AMC 12A. A set of numbers is called sum free whenever x and y are not necessarily distinct elements of the set. X plus y is not an element of the set. So we basically want that if there's any two elements in the set, we don't want their sum to be in the set. And we also don't want double of one number to be in the set. Like for example, 2 times 2, well 2 plus 2 I guess, is 4. And so since 2 and 4 are in the set, it's not a sum free set. We want to find what is the greatest possible number of elements in a sum-free subset of 1 to 3 all the way up to 20. So that means we're basically just using 1, 2, 3 all the way up until 20 to construct the maximum possible sum-free subset. And so, well, I'm going to warn you that right now my solution's a little bit of a sort of a fake solve, but it did work on the test, and it's still good logic and it worked out. So basically, I just started off playing around with a few sets and figuring out what I can have. Say I really want, if I have 1, I can't have 2 because 1 plus 1 is 2, so that's just a given, we can't have 2. So say I only want 2. If we have 2, that means we can't have 4, but we can have 3. But then if we can't have, we can't have 4, we can't have 5. And so we can't have 6 either because it's 2 times 3. We could have 7, but we can also have 8, and I just kept going like that. But at some point, I started to consider parity, and parity is really, I think, the key to this problem. So if we consider parity, let's say we have odd numbers and even numbers in our set, and odd numbers I'm going to denote with this O, even numbers I'm going to denote with an E. If we have odd numbers and even numbers, well, first of all, 2 times an odd number is an even number, so that's already going to cancel out some of the even numbers we can include. So we can't have both odd and even numbers, because if we have both all the odd numbers and all the even numbers, which I guess is just the entire set, well, 2 times an odd number is an even number, and also odd plus even is an odd number. So, we're going to have some odd numbers that can't be in the set and some even numbers that also can't be in the set. And that's not really good because that's a lot of restrictions. So let's say we only have even numbers, so E plus E. And 2 times an even number, 2E is going to be an even number. And also, even number plus even number is also going to be an even number. So if we only have even numbers, we're going to place restrictions on what even numbers can be in the set. So if we have odd and even, well, we have some restrictions. If we have even and even, we have some restrictions. Let's consider odd and odd. Say we have an odd number plus an odd number, and that's really, really key because an odd number plus an odd number is an even number. Similarly, 2 times an odd number is an even number. So if we only have odd numbers, we don't actually have any restrictions on the numbers we can have in our set because, well, they're only odd, so we can't have even numbers, but that was a given anyway, so we don't have even numbers. So the set I constructed was literally just 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and not 20. 20 is not even, or 20 is not odd. And sure enough, it works out because all the even numbers, all the sums of the odd numbers which generate every single even number aren't in this set. And if you try making it any bigger, say I want to add 2 or something, if we add 2, immediately 1 plus 2 is 3, we can't have 3. Or if we don't want to have 1, then 3 plus 2 is 5, so we can't have like any of these odd numbers. It just causes a collapse. And so this was sure enough the largest set that I found because it was just all the odd numbers. It made sense that, well, odd plus odd is even, but we don't want to have even numbers. That's given that we don't have even numbers. But compared to these sets, even plus even, it's given that we only have even numbers, and it's saying that we can't have even numbers. Well, that's bad. If we have odd numbers and even numbers, some mix of them, well, we're saying we can't have some odd numbers, we can't have some even numbers. That's also some restrictions. So, well, these two cases have restrictions. This one really doesn't have a huge restriction, so I just assumed that the answer is just going to be the number of elements in this set, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the answer I put was 10, and sure enough, this is the correct answer. So while this probably isn't the most formal way to solve the problem, the logic here did work out in the end because this is the correct set of, or this is one of the correct subsets that there's not like a sum, it's a sum free. And also the even odd logic provided a very good clue. And if you don't know what to do in this problem, I really highly suggest you just play around with random sets, because that was what I did at the beginning. I just played around with random sets until it just happened to fall upon me that I need to consider parity. And by considering parity, I got to the answer. So yeah, thanks for watching.